tutorial on solving inequalities that have absolute value signs in them. I kind of wrote it out as a 5-step process. If that's helpful, use it. But the overall idea, basically what we're trying to do is we could solve an inequality if it didn't have an absolute value sign here. But because it has an absolute value sign, we need to get rid of that absolute value sign. And getting rid of that absolute value sign is hard to do when we have an inequality. It's a lot easier when you have an equality. So one way to handle this problem is to change it from an absolute value inequality into an absolute value equality. In other words, step 1, just change this less than or equal sign into equals. Seems a little bit weird to be changing the problem. Don't worry, we'll account for that later. So there's step 1 right there. Just do this. Step 2, isolate the absolute value. Okay, in order to get rid of this absolute value, it's a little bit hard to see where the absolute value is because it kind of looks like a 1. In order to get rid of this absolute value, we want it all by itself. So we want to get rid of this negative 10. In other words, we want to add 10 to both sides of the equation. And that gets us here. And then step 3 says remove the absolute value by creating 2 equations, one positive and one negative. I don't know if I worded that very well, but basically what I'm saying here is we can change this one equation into 2 different equations. And the way we do that is we can get rid of the absolute value sign in each of the equations. And then that thing we have on the right-hand side of the equation, well, it could either be positive or negative. What I'm saying is we can leave it alone, just leave it as x plus 10, or make it the negative of that x plus 10. Really the math, what's going on behind this operation is we don't know if 2x minus 1 is negative or positive. You don't know that. If it's positive, these absolute value symbols don't do anything, so we can jump to right here. But if it's negative, what the absolute value symbols do is they change the sign of this entire thing. So they multiply this entire side of the equation by negative 1, which an equivalent thing you can do is multiply the other entire side of the equation by negative 1 algebraically, and that takes us to here. Okay, I guess that's the end of step 3. So step 4 kind of says solve those 2 equations. So my first equation is 2x minus 1 equals x plus 10. And I could solve this, maybe subtract x from both sides of the equation, and then add 1 to both sides of the equation, and you get x equals 11. And then my other equation, I got 2x minus 1 equals the negative of x minus 10. Be careful, make sure you don't leave this as minus x plus 10. You want it as minus x minus 10 because we have to distribute this negative into the parentheses. Maybe you can see that, so maybe really what you have to be careful of is to put the parentheses in there in the first place. It's the negative of this entire side of the equation. But if we were to solve this equation, add x to both sides, and then add 1 to both sides of the equation, and then divide both sides of the equation by 3. And what we've now done is finish step 4. Step 4 was to solve these 2 equations. All right, step 5 is where we're going to make up for the fact that we changed this symbol from less than or equals to into equals to. And so the way we're going to do that down here in step 5 is I'm going to make a number line. I want to make sure that I include 11 So it looks like here's 11 right here. And then I want to go as far over at least to negative 3. I'll go a few further. This would be negative 3 right here. So I've created my number line with the relevant points, negative 3 and 11. And what those are going to serve as is those will be my boundary points. What I mean by that is I'm going to kind of put this line here on negative 3 and a line here on 11. And what that does is it kind of creates 3 regions. We got region 1 over here. We got region 2 in between here. You got region 3 out here. Why are some of them capitalized and some aren't? I don't know. Guess I could make this capital R. Whatever. Creates 3 different regions for you. the way this works out is now all we have to do is test a number in each of these regions. So pick any number in region 1 and test it. And what I mean by test it is we're going to plug it back into our original equation and see if it makes this statement true. If a number in region 1 makes this statement true, then every number in region 1 will make this statement true. So what I'm saying is we want to take our original equation, 2x minus 1, what was it, minus 10? Less than or equal to x. Make sure I copied that down right. And what we're going to do is test a number from each of these three regions. So let's see, where do we start? It doesn't really matter. Let's start with region 1. So from region 1, I can pick any number I want that's less than -3. What number should I pick? Really, it doesn't matter. Test, I don't know, -4, -5, whatever you want. Any number that's less than -3. -3.14 if you want. Any number, it doesn't matter. -4. So test -4. Well, if I tested -4, what I'm going to do is replace every x in this original equation here with -4. And see if this statement is true. So inside the absolute value signs, we got 2 times -4 is -8, minus 1, minus 10 is less than or equal to -4. So -8 minus 1 is -9. And then the absolute value of -9 is +9. And so what we want to figure out is if 9 minus 10 is less than or equal to -4. It's not, because 9 minus 10 is -1. And -1 is not less than or equal to -4. So what that tells us is that over here in region 1, we do not have solutions. The first time I made this video, I made a little mistake here. I wrote 10 here instead of 9. So I'm going to flip back over to that one so I don't have to remake this whole video. But just note that this answer is no, because -1 is less than or equal to -4. Not because 0 is less than or equal to -4, which the screen will now show. All right, let's do that a couple more times, maybe a little bit smaller. Region 2. You test any number. These are going to kind of run into each other, huh? Better, maybe? Region 2. Test any number in region 2 here. -2, -1, 0, some fraction in between, 10, 5, whatever the hell you want. 0 is easiest, I think, because that'll make all the x's kind of go away. So I'm going to test 0. Although you can test whatever you want to test. Let's see. If I do that, I would get the absolute value of 2 times 0 minus 1 minus 10 has to be less than or equal to 0. Let's see. 2 times 0 is 0. 0 minus 1 is -1. So what my statement is saying is the absolute value of -1 minus 10 has to be less than or equal to 0. See, the absolute value of -1 is 1. 1 minus 10 less than or equal to 0. Yeah, that looks good. Because 1 minus 10 is -9. -9 is certainly less than or equal to 0. So region 2 works. Everything in region 2 works. Let's work out region 3. For region 3, again, test anything you want in region 3. It doesn't matter. What should you test? I don't know, 12, 13, 15, 20. If you want to do a round number, it really doesn't matter. I'm just going to test 12, try to keep the numbers as small as possible. So if I were to test 12, I would say, okay, the absolute value of 2 times 12 minus 1 minus 10 has to be less than or equal to 12. Let's see, 2 times 12 is 24. 24 minus 1 is 23. Kind of running low on room here, so I'll jump up here. Absolute value of 23 is just 23. 23 minus 10, less than or equal to 12? No, I don't think so. 23 minus 10 is 13. 13 is not less than or equal to 12. No. Using exclamation points for whatever reason. Region 3 does not work. The only region that works is region 2. Time to change colors maybe. So only region 2 works. So I can now come up with my solution. Everything in region 2 works. So everything from -3 up to 11. So the question is, do you want to include those endpoints -3 and 11? Turns out you do want to include the endpoints in this example because it was less than or equal to. If we didn't have this or equal to, we would not include the endpoints. But in this case, we do want to include the endpoints. So my solution would be everything from -3 up to +11, including both -3 and +11. So this is the final answer of the solution to this absolute value inequality, which hopefully walks you through these little steps of how to solve these types of problems.